Hello everyone. In today's class, let us start discussion about the constraints and their motion. Constrained motion, it is a part of Newton's laws of motion. So, what are constraints and what is its property, actually what kind of rules we need to follow to solve the questions based on the concept? We will discuss one by one. Okay, na? First, constrained motion. What is a constrained motion is? So, it is generally we can describe as restricted motion. Okay, na? A restricted motion means suppose here is the track, this is one vertical track, okay. Next it is one horizontal track, and a rod is connected here with the help of rollers. These are rollers, okay. These rollers will be fixed in the track and they can move along this path itself, and this one move along this path itself, okay, and it won't move away from this path. This roller or this wheel, it is fixed in the track. So, then it should move along this direction, and the latter one this should move along right side. So, then what we have made, this point, suppose if you assume this point is A of the rod for the wheel point, wheel joining point, the A is restricted to move along horizontal track itself. Okay. Now, from the for the instant from here to here, you can see it is not allowed to move other than this path. So, if we suppose it is allowed to leaving for the motion, then it definitely move along this path. So, such a motion is called constrained motion. Okay. So, the same case is applicable for the this one this lateral wheel also. This wheel also move along this downward direction, but along the same path, and it won't move here, it won't move here. So, this kind of motion is restricted. So, constrained to move along this path and constrained to move along this path. Okay. These are constrained to move along the particular paths, right. Then what is the use? Means in some cases, okay, na, the mixed pulley combinations we need to use. Such a constrained motion we can use to be construct lift some things, okay, working heavy machinery objects. So, then we need to know about each point velocity with which they can move, each point displacement, each point acceleration. Suppose if I say this is moving with the speed VA and it is moved on with the speed VB, then what is the relation between VA and VB? We need to find out. So, this relation in finding, we use different illustrations to understand the concept. Okay, na? So, here itself V and VB, you might say generally, if I ask V and VB are they same or not, means general idea purposely you may say VA equal to VB. But as per illustrations explanation is going on, you will come to know how these are related. Okay, na? These are not same, just wait for the slide. I will explain how V and VB are related and what is the relation between V and VB. Okay. So, this motion and these parameters involved in the motion, in such type of motion, we need to find the relation among that parameters. Okay. So, we will learn under the part of constrained motion. Now, next, here first one, rod string constrained motion here, which means rod string constrained motion. Here it is given. This is actually rod and both the blocks are fixed here. Instead of rod you can take a thick string also, there is no problem, which can be explains what the distance. Suppose these are initial position, these are final positions. Now, let us suppose to pull this one up to certain distance. then B has travelled xb distance, A has travelled xa distance. So, here the distance between A and B in both the positions is same. Being it is a heavy thick material, it won't allow to move in between them separately. So, now what happened? A should move along the same path, B should move along the same path, and they are not supposed to deviate their path. So, such a constrained motion, then what are the parameters? Means displacement, velocity, acceleration. We need to make the relation in between them. Okay, na? Suppose it is clear this cannot be displaced separately forward apart from the rod, which means rod को छोड़ के ये आगे नहीं जा सकते, because rod will be stop the motion of the A to move forward. Okay, additional distance we can say, whatever the distance travelled by the B, the same distance travelled by the A, that is no problem. But if you replace this rod with the string, then there is a chance of what A and B travels at different distances. Because of rod fixed and it is rigidly fixed, no. So, then both the displacement must to be same. So, you can see xa equal to xb, one relation we got, and we know that this differentiation of displacement gives you velocity. When differentiation with respect to what we need to do? Time. Okay, differentiation of displacement with respect to time gives you velocity, which explains Va equal to Vb. Sir, here Va and Vb both are same only, na sir? Just now you told that V and Vb how they are related. Okay, this is a simple one we have taken, and you got Va equal to Vb. Okay, na? So, there is some different direction motion involved, the relation between them we need to find out. Okay, na? So, let us take a differentiation of V and Vb also with respect to time, we get acceleration. So, accelerations also same. That is general case, okay, when blocks are connected with the string or rod. Next to second one, wedge block constrained motion. Okay, second part. So, wedge block constrained motion here. So, if wedge is going right side with some velocity, then block kept on the wedge move left to side, and block is constrained to move along this path only, and wedge is constrained to move along this path only, then we need to make a relation between velocities. So, suppose A is falling, means moving downward with the speed Va, and right side it is wedge going with the speed Vb. Then we need to take components here, it is important, sir. To maintain this contact, let us see. First of all, we need to take the components. Vb is the right side, okay, na? And here theta was taken to give the clarity, but actually alpha only we can take, no problem, okay, na? Vb and its component parallel, this is parallel to wedge, okay, and this is what? Perpendicular component. The component which is we have written here, perpendicular component, okay. This is perpendicular component for the wedge at the same, and here it is Va, okay, na? Just it is having some velocity in this direction they have given, means net velocity in this direction they took, okay, na? So, then Va sin alpha along this direction and Va cos alpha along this direction. So, in this case, to maintain this contact, okay, na? The maintaining of contact between block A and wedge B, then we need to suppose to take velocity is perpendicular to this contact, must to be same, okay. You can see here Va cos alpha, okay, na? Va cos alpha, this is perpendicular direction. Next here Vb sin theta, perpendicular direction. So, here these both velocities are made equal, okay. So, now this relation we can use to find out V and Vb relation, okay, na? Here important point is what? To maintain this contact continuously, the velocities perpendicular to their contact must to be same. This point we need to consider, okay. So, now coming to the point, this is the way we can solve the wedge block relations. Next part, pulley string constrained motion here. pulley string constrained motion. So, here general pulley this is actually okay na, A and B blocks are there. So, suppose A moves upward with a distance or displacement XA supposed to be take, and as the string is tight, so then B also move with same displacement. Actually you can take XB suppose, but as displacements are same we can find here. So, XA equal to XB, and the same possible with this case also. If it is moved down by XB, then it is moved forward by XA, then XA XB same only, because string will be in the same means taut position. Okay na, string won't be slink, just it will be in taut position, which means it is moved down. So, then block will come forward. So, the distance through which the block B is moved down, the same distance through which A must be moved. Okay na? So, that is what XA equal to XB here. So, dXA by dt dXB by dt gives you velocity relation. Next, velocity differentiation gives you acceleration relation. Here accelerations, velocities, displacement are everyone are equal in this case. Okay. So, this is the basic introduction part where we can analyze the concept of what finding relations between the parameters involved in the constrained motion. Okay na? So, now let us go some illustration to study and understand deeply the concept of constrained motion. Okay na? Now, let us move on to the next slide. This is one illustration, okay, where a rod of length L inclined at an angle theta. Suppose you can consider this is L and it is inclined theta with the floor against a smooth vertical wall. This is wall. If the end A moves instantaneously with the velocity V1, so it is supposed to go with V1, and what is the velocity of end B at the same instant? Let us suppose to be take it is VB. VB we do not know, VB we need to find, and we need to maintain the relation here VB. Okay na? So, to move this one, let us suppose to take first of all it is having an x displacement from the wall, and it is at a height y displacement from the floor, and it is half length L. So, using Pythagoras theorem, so we can write x square plus y square equal to L. So, suppose I need to do differentiation of this equation with respect to time, because as the time is passed, this end is moved down. So, then this end is moved forward, then definitely there is a change in y, there is a change in x. But at any position of this rod, do we find any change in the length? Means no, the length of rod must be same. So, the change in the length must be 0, because length is constant for whatever the instant may be, and you supposed to take as it is very small particle. Now we can change that. No, you can consider it is as a rigid body. Okay na? So, what is rigid body? I will explain in the next slide just now. Okay na? Just I will explain in the next one, wait for that one. So, first of all, differentiation of this equation with respect to time. Dx square by dt, dy square by dt, dl square by dt. Being L is constant, constant's differentiation will be 0. So, simply we can take here dx square. Actually here x square is there, so we can't do differentiate with respect to time directly, okay na, because it is some mixed function. So, we need to follow chain rule. That chain rule can be applied as like dx upon dt plus dy square by dy by dt equal to 0. Why we have written 0? I told you L is constant. Okay na? So, now you can take dx square by dx, which can be taken as 2x. Let me write dx by dt as easily, plus dy square by dy we can write 2y, and dy by dt equal to 0. Then shift one value on right side. So, we can take 2x dx upon dt equals to 2y dy by dt. Okay, 2 gets cancelled. Now, let us suppose to be take dx by dt equal to y upon x dy by dt. Okay. Now, wait for the writing of some answers. What are that? Let us see. It is a distance x from the wall instantaneously. Then as this x is going to change with respect to time, which explains the velocity with which the end B can be travel the displacement x. So, where I can find dx by dt, then we can write Vb definitely. Okay. And moreover, as the time is moving, as the time is passing, just you can understand B end is moving right side, which means x length increasing. So, we have positive value. So, we can write simply this is as Vb equal to y by x. Next, dy by dt. So, as rod end B is moving right side, then end A moving downward. End A moving downward means here dy by dt is equal to V1 we can write as per the question. So, which explains here dy by dt equal to V1. But as the time is passed, displacement of y decreasing. So, that is what we need to take it is as minus. Okay. So, already when we shift on right side, it should be written as minus. Okay. Now, this is minus. So, this minus we can be written as V1. So, simply we can take this as V1. Then y and x not given, we have taken the values. So, y by x, y is opposite side, x is adjacent side. So, which ratio of a trigonometry comes? Opposite by adjacent value. Which one come? Tan theta. Tan theta equal to y by x. So, simply we can replace in this one like Vb equals to tan theta V1. Otherwise, Vb equals to V1 tan theta. Okay, this is the answer. Okay, na? So, here minus y we have taken as V1. I have given explanation, that is as x increasing, so we have taken dx by dt Vb plus only, and as y decreasing, so minus dy by dt should be taken as V1 not plus. So, that is what here minus dy by dt can be taken as V1. Okay. So, this is the explanation and this is the relation between end A and B relation for the end A and B velocity relation. Okay, na? And now as long as theta remain constant, okay. So, we can take differentiation of this velocity gives you with respect to time, differentiation of velocity gives you acceleration. If theta remain constant, okay, na, then acceleration should be taken as AB equals to A1 tan theta. This is applicable only in the case of theta remain constant. That is it. Okay. So, this is the way we can find out relation between end A and end B. Sir, this is a pretty lengthy manner, sir. So, what to do now in the shortcut? Okay, na? Let us follow that shortcut also, the same question, right? We will see in the next slide. So, you can find here this is the position of rod actually. Okay. So, now you can imagine this is the same diagram, right. Here this one comes with the speed V1 and it one go with the speed Vb, and here it is theta. Okay. So, we need to find out in a shortcut. We have solved in a one slide actually the same answer, and if you listen this is carefully, most of the cases we can solve this one Okay, na? So let us give the relation. Before giving the relation, we need to know about one concept. What is that? You can see, if it is a object and it is definitely a rigid object, it is a rigid body, and if it is a rigid body moving right side with the speed v1, a rigid body moving right side with the speed v1, then consider two particles of the rigid body, not separate particles we placed. Some particles on the rigid body we need to consider that particles also of the rigid body only, not separate. So I have considered one particle here, one more particle here. Okay, these are the two particles, and these two particles must have the velocity v right side same. Okay, na? If they don't have v right side direction, because actually object moving right side, so with velocity v, so that's what these two particles also having same speed in right side, then only we should call this object as rigid body, otherwise we don't consider. Okay, na? Suppose a small example I can give you, okay, for understanding purpose only. Okay, na? Suppose it is a college bus and here are the seats. Okay, students are sitting in the seats here by wearing seat belts. Okay, so supposed to be wearing seat belts, and now the bus is moving right side with the speed v. Then what is the speed of student? If I ask, what is your answer? V only. Direction forward only. Then definitely for an instant, how we have given definition for rigid body, you will be considered, you are not, means your entire school bus is called or college bus is called rigid body, and you are treated as a particle of rigid body. Okay, you are rigidly fixed, and sir, I am just moving inside the bus, means that won't be taken as example. Okay, suppose here you are moving velocity with velocity v right side, and one more, see, because every student in the bus will move with the same velocity na right side, then what is the relative velocity between the first one and second student, means what is the answer here? 0. So v relative v minus v 0. This is also one of the point we need to consider. The object should be rigid when their relative velocity is also 0, means a relative separation is not there between the particles of a rigid body, then only we can consider it is as rigid body. Okay, na? Sir, in the direction of motion of the body only you are saying, suppose in different direction if we can consider, let us. So we can take one direction here, some different direction, okay, na? But here it is making theta and here it is making theta. This line is same for both the velocities, right? So you can take, suppose if you can write this is v1 and this is v2, as we know that v1 and v2 same only, but suppose you can consider this v1, along this direction we can get a component v1 cos theta, and along this one we can take v2 cos theta. So velocities of the particles of a rigid body and their components in the same line must be same. Okay, components of velocities of a particles of a rigid body along the same line must be same. This is very important to solve the question. Okay, once again, this is v1, v2 velocities of particle and their components I have taken along this direction. Why should I, means I am considering this is the line, along this line I need to find relation. So in that direction, what is the component of velocity we get? I am taking, so component of velocity of first one is v1 cos theta, second one is v2 cos theta, and they are lying in this direction. So along the same line these components are exist, so I can take equal. So that's what we can write, v1 cos theta equal to v2 cos theta, and cancelling again we can get v1 equal to v2. Okay, So, this is what we can make a concept development to solve the question. Okay, na? So, I think it is clear about a rigid body and their particles velocity relation. Now, how we can apply the same relation here? Let us see. Here VB is moving right side. VB is I have taken one of the point on the rod, okay na, or edge point you can take. Don't take in the middle, edge part you can take. That edge part velocity right side VB, and if I suppose to take component, so you can understand this is theta means this is theta. VB value how much here? VB cos theta. So, then it is V1, here theta, here 90 degrees, here how much angle? 90 minus theta. So, V1 component how much? V1 cos 90 minus theta. You can understand the concept here once again. Okay, this is one of the edge, end A. Suppose this is end A, this is end B. Okay, end A velocity downward. How much we have? V1 sin theta. Why? Because cos 90 minus theta, first quadrant cos 90, so sin it becomes sin. So, V1 sin theta, and this is the rod and end B. In this direction how much, sir? VB cos theta. So, these both must be equal. So, we can take V1 sin theta equal to VB cos theta. Finally, VB equal to how much? V1 tan theta. This is the answer. If you have any doubt, you can compare and just you can rewind the answer for the previous slide. Okay, na? So, VB equal to V1 tan theta only we got already. Okay, na? You just if you have any doubt, let us see in the previous slide. You can check VB equals to V1 tan theta. The same answer we got here also. Okay, na? For your trial purpose, I will give just changing in the question. Okay, nothing much more change I will do. Just you can see here it is the wall, same concept, same condition, end B, and it is moving downward with the speed V1, and it is move with the speed VB, and if the theta given here, then what is the relation between V1 and VB? That is it. Simply you can find out the answer. Okay, na? So, by using first method, by using second method, whatever it is you can able to solve. You just try to solve this one. Okay, na? Next next slide. Here one more question. Okay, find the velocity of the block B when ring A is moving downward with a velocity V. So, here it is given downward moving. Okay, na? You can see here it is moving downward with the speed V. Okay. So, then what is the velocity of block B? So, whenever it is moving downward, there is a chance of moving upward for the block. So, let us take VB upward. Okay, na? So, now what happened? Again, we can imagine this string as a rigid portion. Otherwise, the point connection for these bodies we can consider as rigid points. Okay, na? So, suppose to take here theta given. So, I am taking along the direction of the string and I can take this is theta. So, what can I write here? This is, suppose here it is not visible, let me, this is V cos theta. Okay, na? Component of V, how much we will get? V cos theta. In which direction we get? Along the string. Okay, na? Next, here it is also along the string only. This is upward along the string. How much velocity we have? VB. Okay. So, then we can write down the answer and we can write down the simple relation, that is what we have along the string means this is same direction along the string you can check. Okay, na? Along the string itself we can take. So, that is what we can write down the answer. Now, let us take here VB equals to V cos theta. That is it. and they are asking velocity of B only. This is V, and cos 60 they have given. Cos 60 is 1 by 2. This is the answer for the given question. Okay na? So this is very simple method to solve the question in this way. Otherwise, length of string we need to take and differentiate the equation as we done in the first method. So you can get that way also, but it is a simple way to solve the question. Why do you make a complication? Okay na? So this way you can solve simply, you will get the answer, right? Next we will see next question. A ring A which can slide on a smooth wire connected to one end of a string as shown in the figure. So it is a ring again here, this is ring, okay na, and supposed to move along this direction. So they have taken other end of the string is connected to the hanging mass B. Here it is mass B and its speed is given beta how much V. Find the speed of the ring when the string makes an angle theta with a wire. So here it is theta given and mass B going down with a velocity V. So at that instant it is going downward with the velocity V. Again we can take simple relation, okay na. So suppose this is V and we can take initial direction of this one is VA, but this connected point along the string which makes, we can take this direction along this direction VA cos theta, okay na. So VA cos theta along the string and here it is connected point and downward direction how much we can take V. So both are along the string connected points only. So simply both velocities must be equal. So we can take VA cos theta equal to V, and they are asking VA. So simply V by cos theta, which is theta value 60 degrees given. So V by cos 60. So V by 1 by 2, which explains 2V. So this is the velocity relation between block and ring, okay na. So very simple way we can solve this kind of methodology of questions, okay. Let us move on to next part. Here onwards we can enter into the next portion like called what pulley string concepts, and base illustrations based on the pulley and string concept we will solve. To solve this one many methods are there, just we use work tension method, okay na, that explains you very easily and that understand by you very easily I hope, okay. So let us solve that one. So before solving that we need to consider some points. What are that points are? First one work done by any force can be taken as force into displacement. That is you need to know. Actually Newton's laws of motion you are hearing means you might not covered work power, because after Newton's law of motion work power energy will come in the syllabus. So if you have aware about any part from the 10th class level, then you will come to know what is work done formula and how we apply positive work and negative work. Even though we can, I am just giving a hint for here, okay na. So let us discuss here. Generally F dot S and here force acting in the body and pulley will be tension. So that's what I took here, T it is, okay na. So T dot S, otherwise or T dot S we won't take, means F only you can write, no problem, okay. So here Fs cos theta for any angular position we can get, yes. So by depending on the theta only we can define work done, whether it is positive, negative or 0, okay. So we can write down if theta equals to, here Ts cos theta I am writing. So Ts cos 0 explains Ts which is positive work, and Ts cos 180 equals to Ts, it is negative, okay. So that is your negative work done, so your positive work done, okay na. So that explains here how to take negative, how to take positive, then depending on what displacement tension acting at that position. So, I will explain tension in which direction it is acting and in which direction it is displacing, we will find that one. According to that, we need to write here negative means I have written negative here, actually we need to take its answer is minus Ts for more clarity. Okay, na? This is to be taken as minus Ts, this is positive, so positive only, plus Ts we can take. Okay. So, now this is first one, work done by the any force. Here work done by tension I took here, tension and displacement I take. Okay. So, now after this one more point, work done, sum of work done by the tension, sum of work done by the tension on the all pulleys of the system. Okay, here on two blocks here, on two blocks, here two blocks. Okay. So, work done by the tension on all blocks of the system is must to be 0, not pulleys, blocks only we can consider. Okay, na? So, here how many blocks are there? 2 blocks. So, that is what work done by tension on these 2 blocks sum must to be 0. That is clearly we can take. Why? Because it go upward, then it goes same downward. So, then work done must to be equal to 0. Such phenomena we can apply here. Okay, na? So, these 2 points are very essential to understanding and solving this pattern of questions. Okay. So, just we can follow work tension method. How to solve? Let us start see here. First of all, we need to identify the tensions in the string. If one string, then tension must be T only, there is no change. If the string is a different part, then tension will be changed. Let us start here a long string here, this is a connected long string. So, I am taking tension T acting upward because it is always acts opposite to point of contact, right. So, here at this point downward, the same tension transfers, here it is downward, here it is upward, again here it is upward, here it is downward. Okay. So, here it is fixed rigid only, no need to write down any kind of value here. Okay. So, then this T, this T, here it should be balanced with 2T, downward 2T, upward 2T. So, because of this one here it is add up, 2T only acts. Okay, na? Then after we can develop the part, and masses are not given, just we need to make a relation between parameters of A and B like displacement, velocity, acceleration. Okay, na? So, suppose to take here, I am taking A is moving upward, then B mostly move downward. Okay, na? So, suppose I am taking XA, this is, and it is XB, that is we need to take. Now, sum of, we have discussed that sum of work done by the tension on all the blocks of a system must be 0. So, first point according to that only we can write work done on A plus work done on B equal to 0. Okay. So, now work done on A, work done on A is what is the force acting on A here? T acting. So, tension T acting and displacement is upward XA. So, both are in same direction, T XA cos 0 we need to write. Okay, na? That is T XA cos 0 plus what is the force acting on block B? 2T. 2T acting upward, but block moving downward. So, here how much angle between force and displacement? 180. So, simply we can write 2T and XB cos 180 equal to 0. So, then here we can take TXA where cos 0 equal to 1 only, sorry, here it is not equal, just we need to write plus 2T XB, here it is minus, so we can write it in bracket equal to 0. Okay, na? So, this minus shifting on right side become plus. So, TXA equal to 2t xb, where tt cancel, xa equals to 2 times of xb, which means when 2 meters of displacement covered by block B, okay na, then XA covers by 4 meters. Next, XB covers by 1 meter, then XA covers by 2 meters of distance. So, if we can conclude here, XB equal to 1 meter, then XA equal to 2 into 1, 2 meters of distance. So, in the same ratio only velocities also can be solved, okay na. So, suppose we can write down here XB equal to, XA equal 2XB equal to XA, okay na. So, then differentiation 2XB by dt equals to dXA by dt. So, then differentiation of displacement with respect to time, velocity. So, this is 2VB equal to VA, and further differentiation of this velocity with respect to time gives you acceleration, that we can write 2 acceleration of B equal to acceleration of A. So, in the coming questions and later on practice questions, you need not to do differentiation, okay na. Directly you can find the relation. Instead of x you can write V, instead of x you can write A if they ask relation for velocity and acceleration. So, then you can solve the answer directly, okay na. So, this is the method we follow to get the relation of acceleration, velocity, displacement relation in the pulley block system, okay. So, this is what work tension method to use to find the relations, okay na. Next, here one more illustration, that is 2 blocks are there and here pulleys is different way connected, and we can solve same method only again, okay na. So, let us suppose to take, here is the tension starting point I am taking, okay. So, upward T with respect to this point, okay na, and with respect to this point downward, the same tension will follow with respect to this point upward, okay. Now, with respect to this one downward and here with respect to downward T, this T balances here 2T, okay na. Here T balances 2T, okay. Now, this 2T transfers in this direction and here it acts like 2T. So, now just you can analyze the forces. On A, 2T plus T, total 3T is acting, and on B, total force acting by how much? T. So, we can take here, suppose A is moving downward, displacement with XA, and then block B is moving upward with the displacement XB. Then what is the relation we can take, okay na. So, let us take the concept here. So, 3T XA cos 180. Why should I write? Means XA downward, 3T will be upward, but both of them angle between them will be 180. So, next work done on the A block, next work done on the B block, XB upward, tension also upward. So, we can write T into XB cos 0 equal to 0, because total work done on the blocks will be 0. So, we can take 3T XA, here it is minus, here T XB equal to 0, because it is 1, it is minus 1. So, minus I have written here. So, minus shifting on right side become plus. So, 3T XA equal to T XB. So, TT cancel. So, finally 3 XA equal to XB, and we can write the same kind of way relations for velocities also like this, and accelerations also like this, okay. This is the one of the simple way to solve the relation between velocities of the blocks, displacements of the blocks, accelerations of the blocks, okay na. Next, Here it is one more complex pulley, okay na, in which find the velocity of C, it is given here, okay. So now let us take here velocity of A downward 3 meter per second and B also downward 5 meter per second, and C we do not know whether it is going downward or upward. We need to find that velocity direction also. So suppose to take first a long string. So in that long string we will display what to write the tension. So we can write down here, this is T, and with the respect to point this is again T, and here it is T. So next here also T, here also T. Now you can write here T becomes add up 2Tx, and here Tt becomes 2T, here it is x, okay na. So now here directly values given. So I told you T into x, instead you can take T into V also, okay na. So by differentiation with respect to time only, so you can equate and time cancel, then displacement relation will come, no problem in that one, we can take directly, okay. So now here 2T upward, velocity downward, here also 2T upward, velocity downward. These both the values of work done must be negative, okay na. Suppose you can take it is XA and suppose you can take it is XB. Let us see where it is going, upward or downward, okay na. So mostly it is, we can observe that upward only it will go, okay. But if you take downward also, no issue, you will get the answer as minus. If it is going downward and you took direction upward, then minus will come, and if it is going downward you took downward, then answer will come plus. There is no problem. Magnitude वो कुछ भी problem नहीं होते. The magnitude of velocity will come as it is, okay. But direction only explains from the answer. Whatever the direction in which actually the block C go and you choose the same direction, then answer will be plus sign. Otherwise it will come in minus sign, okay. So let us see here, I am taking it is going upward with a covering of XC displacement. Work done by the tension in all the blocks, on the all the blocks must be 0. So 2T XA, this is minus only, next to minus 2T XB, next to plus T XC equal to 0, okay. So here just I have written directly XA downward, 2T upward, so minus work done, 2T upward, XB downward, minus work done, minus minus, and T upward, XC upward, so we will take it as plus. Then total work done equal to 0. So simply here minus terms should be taken right side, T XC equal to 2T XA plus 2T XB, T cancel, XC equal to 2XA plus 2XB, differentiating with respect to time, VC equal to 2VA plus 2VB, okay. 2 times of VA is 3 plus 2 times of VB is 5 here, so 2 3 is 6, 10. So I got the answer plus, means I took the direction upward, then answer come plus only. So our direction of choosing and actually the block move in the same direction. So that's what we get answer plus, okay na. So next let us move on to next slide. Here one more, find the velocity of B they have given, okay na. So here we need to solve the question by taking assumption here. Let us take from here the tension first. Here it is T, here it is T, then in this value it becomes 2T, okay na. Then and here it is 2T, here it is 2T, then 2T add up, here it gives you 4T, okay. So now B velocity they are asking, one is moving downward, one is moving upward, and here it move upward or downward, we don't know, we need to solve this one, okay. So let us take its displacement downward xc, and suppose I am taking its displacement upward xb and it is moving upward, they have given xa. Okay na? Work done by the tension on all the blocks must be equal to 0. Let us suppose to take 4t into xa, that is positive only because both are in same direction, plus t into xb, I took upward only, so plus, sorry, here it is minus of t into xc equal to 0. Okay, we want xb, so we need to make it as here. So txb equal to txc minus 4t into xa. So t cancel, xb equal to xc minus 4xa. This is the constraint relation in displacement. Okay na? Now differentiate the answer and we will get velocity and we need to substitute. Differentiation gives you Vb, Vc minus 4Va. Vc how much? 4 minus of 4 into Va 3, 4 minus 12. So minus 8 meter per second. So minus km. So no problem. Okay na? Whatever the direction we choose to go this one, okay, that is wrong. So it actually moved downward. That's what we will take. Actually we need to take it is downward, but we have chosen upward, but answer won't change. Only symbol will come minus place. Okay na? Minus 8 meter per second, then the block must be go upward, sorry downward. Okay na? So that is right answer. Now next, here find the velocity of b they are asking. Okay na? So with what velocity the b will be fall or move down. Okay na? Whenever it is having velocity v1 left side. So here suppose it fall with a velocity v2 here relative to a, if I choose, not with respect to ground. Okay na? Suppose then what is the velocity with which it falls with respect to ground, we need to find out. So to find out this one, we need to take the concept like here you can check. One velocity it is having, so frame will be makes here difference. Okay now, before starting the question, frame is important, right? So now it is moving down with velocity v2 with respect to weight ga, not with respect to ground, clearly. Okay na? For suppose a person stand on the ground and he observe this block, how it is going to be move. So for person on the ground, the block should appear like, you can see, just I am drawing this block. Block has velocity v1, left side being it is on the wedge, and it can slide down with velocity v2 with respect to a. This is I can take as vba. Okay, this is I can take as va. So this angle was given theta, and the net velocity observed by the person on the ground, that must be in between velocity of b with respect to ground. Then what is supposed to be angle between them? 180 minus theta. So simply we can write this is 180 minus theta. So one of the component along this one and one of the component along this one we can take, and we will find out VBG. Otherwise just we can take VBG. So you can write a velocity of b with respect to a equal to VB plus VB minus VA beta, not V plus. So relative velocity always defined for two dimension system VB minus VA. Okay, these are defined with respect to ground only, right? We want a pure velocity with respect to ground. VBG equal to VBA plus VAG. Okay, but if these are having some angle, so then vector addition we should follow better. So that is VBG magnitude equal to root over VBA square plus VA square plus 2 VBA VA cos 180 minus theta. This is answer. Okay. If they give velocities V1 and V2, we can put it in this one and we will get the answer, right. So, this is the way we can solve actually what is the velocity of B with respect to ground. And with respect to wedge, we have already seen in the previous case, we can take its components perpendicular to this direction, we will get the answer. Okay, na? So, next here one more point, find the velocity of B, they are asking. Okay, na? Here with what velocity it will go upward. So, we need to find, right. Let us see. Suppose it is covered a displacement x, means this wedge A covered a displacement x. Okay, na? Then this pulley also fixed for A only. Then it is also come for backward, means left side at the displacement x. Then how much string become loose here? X, right, and it fall by a distance of x undoubtedly. Okay. When it is moving left side with the x distance, this block also fall distance x, because this pulley move backward or left side with the x distance, then string lose the same distance x. So, then that string become taut, then it is the B must be also fall downward with a displacement x only. Okay. So, you can understand here, this is the new position of the wedge. So, here is the block B, it is going downward, okay, na, with the displacement x only. So, with respect to A, its velocity V only, we do not have any problem, but it is being on the wedge, so it is having velocity left side as we have solved in the previous case. Okay. Once again diagram, this is block B, it is falling downward with velocity also V1. Why? Because suppose generally we can take what xb and it is xa, we used to take, na, but as per the concept what we can write out, beta, if it is going this side xa, the same string loose and come this side, and block B also move the same distance xa. So, then xb equal to what we can write? Xa. So, I need to say that whatever the terms I have used in the last questions, xa, xb, that is what I have written in terms of xa, xb, but xa, xb both are same. So, we can write here, this is xa equal to xb, just simply we can indicate. So, xa is having speed how much? V1, and xb must be also have the speed v1. So, here this left side direction we have the speed v1, and being it is theta angle forms, and this angle must be 180 minus theta, v1 same, so exactly middle only the value will be present. We do not want to use that vector addition, magnitude of vector also, directly we can take the component. This is velocity of B with respect to ground equals to v1 cos 180 minus theta by 2 plus its component also v1 cos 180 minus theta by 2, because this is exactly half, this is exactly half, you must, okay, na, because velocities are same. So, then definitely it should act in the middle portion. So, final answer 2v1 cos 180 minus theta by 2, this is VBG, this much, okay, na? So, this is the answer, and here velocity of B with respect to A is must be V1, there is no change in the answer, okay, na? Next question, here two blocks are there and one wedge, okay, wedge is moving left side with velocity V1, then B is falling with velocity V2, okay. Then what is the velocity of C with respect to ground they are asking. So, then C has two velocities, one is upward, one is right side, left side. So, here it is V1 and you can see how much distance through which it fall, through same distance c will rise. So, if it is going downward with V2, then this speed also V2, that is it. Okay na? V1, V2 for there for the C as shown in the direction. You can see here, this is having V1 velocity because of A, and this is having V2 velocity because of B, and net velocity of Vc with respect to ground. So, Vc with respect to ground must be V1 vector plus V2 vector, since the angle between them is 90 degrees. So, magnitude of the vector magnitude we can write V1 square plus V2 square. So, this is VCG magnitude. Okay. If somehow they ask the angle at which the net magnitude is going to act, we can find. So, tan theta equals to, what is opposite side V2 and adjacent side V1. So, theta equals to tan inverse of V2 by V1. Like this we can find out. Okay na? So, next. Here is the velocity of block B, they are asking. VA is given. Okay, block only, like a wedge some variation we can take here block kind of question. Okay na? So, this block is initially going right side with a speed of VA 5 meter per second. So, we need to analysis like here. If A is moving right side x, then pulley also move right side x. Okay na? As pulley move, how much string here become tight? X only. Then how much height it will rise? X only. So, are you getting clear? Once again, as the block A moving right side x meters, then the pulley is fixed for this one rigidly, then pulley covers right side. When pulley covers right side, the string loose and the string pass over the pulley x only. Then because of this string B rises by x. So, which means we can consider this is block B and it go upward, VBA is exactly 5 meter per second. Sir, how did you write directly 5 meter per second? So, what is the velocity of A? 5 meter per second. It is covered x displacement, then it is also covering x displacement, and if you want to write from the beginning, XA equal to XB, differentiation of this equation gives you VA equal to VB. So, that what I have written. But here VB is not with respect to ground. It is very important. Why? Because VB with respect to A only we have this much value, but with respect to ground we have different. That is what? See, B is not only moving upward with respect to ground person, it is also move right side. That is VA speed only it can have, right side speed 5 meter per second. So, the person who is observing VB with respect to ground, this in this direction it will be. So, since 5 and 5 it is exactly middle 45 degrees only it works out. Okay na? So, from the concept of VBA, VB minus VA. So, we have VB equals to VBA vector plus VA vector, VBA upward, VA right side. So, angle 90 degrees. So, we can write 5 square plus 5 square, we can have 5 root 2 meter per second. Okay. So, this is the answer for VB with respect to ground. Here two velocities are there. One is with respect to block A, that is x, that is VBA 5 meter per second. The same block velocity is asked with respect to ground, we get 5 root 2 meter per second. Okay na? So, this is the way we need to solve this model question. Next model, and don't be shocked by seeing this much pulleys, and I will say that easy method to solve. Okay na? Don't worry about this one. First of all, find the velocity of B if VA is given 5 meter per second. Okay na? So, let us see here it is going with a speed 5 meter per second. So, again you can consider as it is going right side with a displacement of x. So, let us see, this gives you x, okay na. This gives you x, okay, and now here this gives you 2x, not x, one string, two strings, and this gives you 2x, and this fully attached to this one, so it will gives you how much x. Total how much length of the string it should be raised here. Actually, to saying this x na, it is multiplies to be raise the black b. Okay, you can count x, 2x, 2x, 5x plus x, total 6x displacement covered by the black b. Okay na. So that is what we can write here. This is x actually. So it raised by 6x. So this is what actually xb, right? So xa equal to x and xb equal to 6x. So we can take xa velocity suppose v, then xb velocity, sorry, don't consider xa beta. Like this, x is this much, okay na, and xb is 6x. So we need to take the velocity. If a is moving with the speed v, matlab means va equal to v, then what is vb equals to? Vb that to respect to a, okay na, it is not respect to ground. Vb respect to a only we are finding because it rises. As one can see from the ground, it will move in this direction, not upward, not forward. Okay, we are finding upward. So better you write here it is VBA, 6 times of VA. Simply we can write. Okay na? So then again block B as a velocity, two directions. So we can write here right side 5 meter per second, upside 5 into 6, that is 30 meter per second. Okay. So then VBG is equal to 5 square plus 30 square, 25 30 square here 900, which is 925 root meter per second will come. Okay na? So this is the way we can solve velocity of B block with respect to ground. But B block with respect to A, simply we can take 6 times of VA. That's it, because A covers a displacement x, then B covers a displacement 6x. So differentiating this x value, we will get a velocity. Okay na? So now one more trick I can say you to find out velocity of B. Okay na? Always you can choose a x distance travel. Okay na? You can count 1, 2, 3, 4, 5, 6. Then it should definitely covers 6x displacement. That's it. How many horizontal strings are there? That much distance of A. Okay, that many times distance of A covered by the block B. Okay na? And vertical side also there, suppose, don't count, because for any position vertical string length will be constant. Don't consider that value. Okay na? So only horizontal portions we need to count, right? So by seeing this much complex pulley, don't hurry first of all. The methods are there here. So I am just expressing to solve this question very simply, and you try to learn this method and you can able to get the answer. Next, here wedge, okay na, when actually one A block is there, it is confined to follow in the same direction, means constrained to move in this direction. What is given in the question? A rod moves vertically downwards on the surface of wedge A or wedge B, as shown in the figure. Find the relation between the velocity of the rod and that of the wedge at any instant they have given. Okay na? Given VA equal to 5 meter per second and theta is 60 degrees given. So we need to find VB. Okay na? So let us take here, first of all, this A is falling downward and B is moving right side. Okay. So suppose to consider here, just we can take like this diagram. So it falls at any instant also it falls vertically downward because these are supports beta, and these supports does not allow A to fall in any orientation, it should definitely fall downward only. Okay. So for an instant I took this is going with a displacement x and it falls a displacement y. So let me take for an instant suppose like this, and it has already fall down like this, it was fall down. So I can take this is x and this is what, y. So now it is angle theta. So tan theta equals to how much beta here, y by x. Y is the distance covered by a, so y equal to x tan theta. Theta must be constant, and differentiating we get VA equals to VB tan theta. Okay na? Actually VB only asking na, right. VB equals to VA by tan theta, where VA is given 5 and theta value 60. So finally 5 by root 3 meter per second, like this we can get. Okay na? So otherwise you can take the components of A downward, okay na, and VB like this, and at the point of contact we can take the values perpendicular direction, their values must be same. Okay, that is second method. This is one more method I have introduced here, so in which we can follow to get the answer. The answer is here, same answer we got. Okay, so this is what regarding some constraint based concepts and their illustrations, and you need to get the most practice on this kind of problems to get analysis and to get a practice. Okay, and mostly when we solve more and more types of problems, you can get the tricks to solve different types of questions, because I say this model question, then you can solve this model of question only. But whenever we can apply the concept, like here it is the point of contact, perpendicular to this point of contact velocities are same, no? That velocity is, this concept you can apply for many cases. So when you solve that questions, you will come to realize, yes, this method can be applied. Okay. So without solving, without imagining only, you can't get the concept perfect, right? These are some questions and illustrations based on what constrained motion, right? Thank you.